we're looking at, well, what is this last chapter? Give me a big picture. What are we looking at? Lipids. Lipids are another name for lipids? Fat. Okay, so hydrocarbons, things that are organic chemistry based, and so we're looking at all sorts of things. We looked all the way back from the molecule that is storing in energy to the molecules that are part of lipids that are in the membrane to lipids themselves as functional entities. This is a class of functional entities called the eicosanoids. They are signaling molecules that signal local or very short distances. They are derived from arachidonic acid, an essential fat that we must eat. All right, so when that particular fat is broken off, then it can be processed. And it is processed into 4 different classes of signaling molecules. First one, leukotrienes. Next one, thromboxanes, prostaglandins, and prostacyclins. These are the molecules that are given off. Now you can see they are the derivatives of that arachidonic acid itself, but it must be processed. And so what we are going to see, though, in this is an action of a drug. Now, one of the oldest drugs that is used medically is aspirin. For a long time, it was used, but they had no idea what the mechanism of action was or how it actually worked. There are actually some processes of aspirin that we still don't understand why it works the way it does. But you take aspirin to do what? Decrease what? Pain and inflammation and fever. Okay? And so it works in those particular mechanisms by blocking an enzyme called COX-1, which does this reaction here. Okay? So if it stops the conversion of arachidonic acid, then some of these molecules might have to do with inflammation and pain and fever. So if we take a look at each of the different classes, prostaglandins themselves, okay, there are 2 classes, one called ether-soluble and one called buffer-soluble. Okay, this goes way back to when there were no biochemists. Before there were biochemists, there were organic chemists that dealt with biological systems. And so if we were going to separate something from that is soluble in water and from something that is soluble in ether or an organic solution, what is the instrument that you use? What's the piece of equipment you use to separate things? That if you shake it up, it might explode on you? A piece of glassware? How many people have taken organic lab? Only a few? Okay. You put water in it, you put ether in it, you shake it up, and you have to vent it. A what? A funnel, a separatory funnel, a sep funnel, yes. And you get things that are dissolved in the water, things that are dissolved in the ether. The ether is the organic. That's where we actually found these first, was separations of that type of analysis. And so we're looking at the ether soluble, and so the prostaglandins fall into that particular category. And what they tend to do is influence the second messenger cyclic AMP and stimulate contraction of the smooth muscle. This leads to inflammation, pain, and fever. And so if I block the formation of this, I reduce inflammation, pain, and fever. The thromboxanes and the prostacyclins control platelet aggregation, and which is clot formation, and they also have vasoconstriction. And so when you're cut, you tend to have these produced so that you can reduce the blood flow and clot it so you don't bleed out. But also that reduction in the vasoconstriction can also lead to pain response when these are released. The leukotrienes, okay? Didn't know what a leukotriene is, but someone made a commercial for it. It's a commercial for Singular, and they say, Singular blocks leukotrienes, and which cause allergic reactions. And so they threw in a scientific word, so it must be good. And so it is actually a different type of molecule that works against reactions. The other type of molecules that actually work that way is the antihistamines. This was a newly found molecule that prevents the allergic responses. And an example would be leukotriene D4. It particularly induces constriction of the muscle linings of the airways, which is one of the reasons why you might have an asthmatic attack. And so if you block the leukotriene, you can block the asthmatic symptoms. And so it is triene because you have the 3 conjugated double bonds. And so those are the types of molecules that can be given off as signal molecules that really only affect very close cells to where it's being released. Lipids can also be vitamins, and we have a whole set of vitamins that cannot be synthesized but must be eaten. There are 2 classes of vitamins, water soluble. We're actually looking at the fat or lipid soluble, and we have 4 groups, A, D, E, and K. We've already looked at D before, and A and D are actually precursors that need to be modified in vivo to become the active hormone. Vitamin A comes from beta-carotene, and if you break the beta-carotene at the middle, we get vitamin A or retinol, which then can be produced and made a derivative to make retinal, and those are the light harvesting molecules in rods and cones for our vision. And so we say, or there's a wives' tale, to get better eye vision, you eat what? Carrots. Carrots have lots of beta-carotene. And if you have lots of beta-carotene and you eat and eat and eat lots of beta-carotene, what happens? You become orange. Okay? Can you eat enough carrots ever to get rid of your glasses? Absolutely not. We're not going to improve your eyesight in terms of clarity and sharpness. Okay? Because that's an issue of your cornea and how the light bends. But what are we going to improve? Well, if we have more of the retinol, that becomes the retinal that can be in the rods and cones, we can see in darker conditions, and we have less vulnerability to having night blindness, like riding down the road and getting hit with the brights from someone else. And so you don't overwhelm all of your rhodopsin, which is the protein that absorbs light, that uses that. If you have lots and lots of that, you can have better vision in terms of night vision. Vitamin E, now added to all creams that are supposed to help you not age, is an antioxidant. It's an antioxidant that is very soluble in the lipid structures or the creams that are sold, and you'll see vitamin E quite often in topical manufactured products. It is a natural antioxidant, and it can react with free radicals, which is intended to stop aging. We think that oxidative damage is one of the reasons why we do age. Vitamin K is a vitamin that is a blood clotting molecule, and so it's part of the cascade of events that allow clotting to occur. Now, if you take a look at vitamin K and you take a look at vitamin E, what in the world is the difference? A whole bunch? Is there a whole bunch of difference between them? Not really. And you see that repeating tail at the end? That's very, very similar. There's a ring structure. In this case, most of the vitamins are polymers of this repeating 5-carbon structure. The last one that we will look at is Q. And I have Q from the animal system, and I have Q from the plant system. Really, the only difference are methyl groups or ester groups, methyl esters, but those carry electrons. And they have very similar structures to all of those other vitamins. In this case, though, the 5-carbon repeating intermediate has an unsaturation where some of them are fully saturated. So they are all very similar in terms of their structure and thought to have been derivatives of each other as we increase function within our biological system.